Hi, I'm his brother, and we both wanted to game at the same time. But due to crypto mining, GPU shortage, GPU scalpers, everything's too expensive. We couldn't afford two computers, so this was our solution.
So what we got here is we got one computer, and it's got two graphics cards and one of everything else, and we're sharing it. We're both able to run games at the same time, and we're not using virtualization to do it. This is not a bad experience at all.
No, pretty good. It's running smoothly.
It's running perfectly smooth. I know you've all seen that video, 2 gamers, 1 CPU. But that system used virtualization. There was an operating system acting as the hypervisor, which had its own graphics card, probably integrated graphics, plus 2 discrete graphics cards, each being passed through to a virtual machine. The system was being partitioned discretely, with each virtual machine being a completely separate install of Windows, with its own memory, its own emulated hard disk, and its own physical graphics card. One user on the system could not use all of the resources. At most, they could use half. But that's not what I'm doing here today. What I have is one system running Linux. Both of these users are logged in to the same system. Each of them has their own desktop, their own keyboard, monitor, mouse, and to them, it's like a separate computer. Each user in this setup does have access to complete hardware acceleration to one of the graphics cards in the system. This works for OpenGL and it works for Vulkan. This technique is called Linux Multiseat, and it's a feature that Linux has supported for a long time, but in recent years has gotten much easier to implement. In this video, I'm going to walk through how to set up Linux Multiseat with full graphical acceleration for all users. The only stipulation here is we need a separate graphics device for each user. In this case, I'm able to use the integrated Vega graphics on my AMD APU for this user, and I'm able to use my RX 580 for that user. So I don't need 3 graphics cards because I don't have a host and I don't have a hypervisor. I don't need to deal with the hassle of PCIe pass-through to virtual machines. And all of my programs could potentially use all of the RAM in the system if they wanted to. So let's talk a bit about hardware. What hardware am I using today? This is my test bench. It's really the only system I have that's free. You've seen it in some of my other videos, like my 7 desktops RDP video. Link up there for that one. It's an AMD Ryzen 5 3400G, which is part of the Zen Plus family of APUs with Vega graphics, also known as Raven Ridge. It's on an ASRock B450M micro ATX motherboard with 32 gigs of RAM and a dual channel configuration. In addition to the integrated Vega graphics, I also have a Radeon RX 580, which is a Polaris-based GPU. I've specifically chosen to use all AMD graphics cards for this build. In theory, you should be able to mix between Intel and AMD. However, I can't test that to verify. According to reports that I've read, it's not possible to use this with NVIDIA and AMD mixed, although it should work with a pure NVIDIA or pure AMD solution, mostly due to the proprietary nature of NVIDIA's Linux drivers. So first we're going to go on a trip into the BIOS. Make sure all the settings are right here. In my particular setup, the primary video adapter had to be set to integrated graphics. I found on my motherboard with my BIOS, if I didn't set the primary video adapter to integrated graphics, then it would disable the onboard graphics entirely, which is something we really don't want. Whatever you set this to is going to be very important later, because our primary video adapter has to be our first seat number 0. If we get that wrong later, it'll have problems booting up. So now we're going to install Ubuntu. So for this project, I've chosen to install Ubuntu 22.04, which is Jammy Jellyfish. As of the filming of this, it's still in beta, but when this video comes out, it should have been fully released. I'm going to elect to install this with ZFS on root. That gives each user their own dataset and home directory. It also gives us the option to enable deduplication if we want to. If you have a bunch of users and they all have their own Steam library and their home directory, you can deduplicate them with ZFS. Next up is the user. I'm going to call myself Multisystem. So while this installs, let me give you a little bit of backstory about how I came to this project. So I've been using Linux for a very long time. The first version of Linux I ever used was Ubuntu 6.06 Dapper Drake, which, as the name suggests, came out in 2006. Back then, I was running a PHP BB server for my friends and I to communicate. We had basically no security, but the internet was different back then. Sometime later, I found a Wikipedia article which had a great graphic. Graphic showed a 90s era beige computer tower connected to 4 CRT monitors, beige keyboards, and beige mice. And all 4 of those CRT monitors were hooked up to that one computer. To say I was impressed with what Linux could do was an understatement. But back then, I was in high school and I couldn't figure out how to set it up. But that image of those 4 beige CRT monitors with that one beige tower has stuck in my mind all those years. And I knew that someday I wanted to come back and set up a true multi-seat Linux system. So as Linux has evolved, support for multi-seat has gotten both easier and harder. Back in the day of the beige box, there wasn't much hardware acceleration to speak of on a basic desktop. Video encoding back then was still done in Flash, if you remember Flash. So it wouldn't be too unreasonable to connect an X server to every single VGA port on the computer, or throw in a bunch of PCI VGA cards if you really wanted to. There were also USB options back then, and there still are USB 3 video cards now, which I might come explore in a future video. So now, software support in Linux with systemd has greatly improved the ease of use of multi-user, multi-seat systems. It's pretty easy now with the mainstream desktop environments and display managers to choose which resources you want to allocate to which seat. In my case, I'm picking which keyboards, which mice, and which graphics cards are going to go where. And systemd and login control just kind of figures that all out. It works very well. What's harder about doing it now is that 3D acceleration has become very prevalent, and it's pretty much an expectation that every desktop has 3D acceleration for video decoding and things like that. So that's where the requirement for one graphics card per user comes in. The Linux developers are concerned about the security implications of allowing more than one seat to have access to the video memory on the same graphics card. So we're going to restart into this install. Then we're going to set up systemd login control in each seat. So at this point I'm going to plug in my second monitor. I don't have 2 screen capture devices, so you're going to have to bear with me. So during the boot process, our primary GPU is the one that goes through the initial early stage bootloader. At some point in the boot process, the Ubuntu logo is going to show up on all of the monitors. That's a good sign. So the login screen showed up on the monitor. I'm not screen capturing, so I'm sorry. Now we got our Ubuntu desktop. So here we go, running updates like we always do. I'm also going to install OpenSSH server, and that's mostly just so I can view Radeon Top remotely. And if we make any really big mistakes, we can probably correct them over SSH. And I'm using the built-in AMD GPU drivers that come with this kernel version. And for Ubuntu 22, that's kernel 5.15, and they seem to work just fine. I am going to install Radeon Top, which is a utility that shows you usage of Radeon GPUs. So if I run Radeon Top right now, you can see it found Raven on bus 07, so the PCIe address starts with a 07. So one final housekeeping thing we're going to do before we start adding multiple seats is we're going to get rid of Wayland. So Wayland is an alternative desktop protocol to the traditional Linux Xorg server, and it has some benefits, but I found it does not work as well with multi-seat yet, so we're going to switch back to the Xorg server. So for GNOME-based systems, we need to edit etc gdm3 custom.conf. If we comment out this line that says Wayland enable equals false, it'll disable Wayland and just use Xorg. So we'll save that. Now we're going to reboot. And once we reboot, we should be ready to start adding devices to the second seat. So now before we can continue, we need to figure out where our GPUs are located on the PCI bus. So we're going to use LSPCI. So we scroll up here. So we have a number of devices that start at 0. That seems to be the Raven Ridge root complex. Then at 01, we have Ellesmere, RX 470, 480, 570, etc. So that's going to be our RX 580 here. So PCIe address 0100.0. And then there's also HDMI audio, also from the RX 580. So the RX 580 is at 0100.1 for audio. Scrolling down a bit further, we have 07 VGA compatible controller. So 07.00.0 is our Raven 2 Vega mobile graphics. And the .1 of that is our audio. So we're going to pass through the 07 device to one of our seats and the 01 device to our other seat. We need to choose which one goes to which seat. So, like I mentioned earlier, whichever graphics card is your primary video device, the one that the system boots up with, that needs to be attached to seat 0. That means that seat 0 is going to have our Radeon Vega graphics from the Raven Ridge. And our second seat is going to have the RX 580 Polaris graphics. So if I run Radeon top and I run Heaven, we'll see what it does. So we can see our utilization on the Raven CPU is spiking up to 100%. If I open a new tab, Radeon top takes an option -B, which is bus, and you give it the first hex digit of the PCI bus where the graphics card's on. In this case, 01 would be our Polaris card. So our Polaris card is showing about 4% load, which is not that high. And our Raven card is being pegged. So now we're going to look at all of the hardware available to pass through to more than one seat. And we're going to use a tool called login control for this. It's part of System D. So if we ask it to list seats, it tells us there's one seat right now and it's called seat 0. So our goal is to add a second seat, which we're going to call seat 1. But first we have to figure out what hardware is already attached to seat 0. By default, all new hardware in the system gets attached to seat 0. And we're going to write some rules that change some of these devices to get attached to seat 1. So here's a list of all the devices we have on seat 0 right now. Some of them are pretty basic. Power button, video bus. Then we have this PCIe 010000 card 0. This is going to be our Polaris card, the RX 580. Notice it has this tag on it that says master. That means that it's capable of being a master of seat. When you create a multi-seat system, you need at least one master for the seat to exist. If I start adding a bunch of keyboards and mice to seat 1, it's not going to spawn a new graphics session just for those keyboards and mice. There has to be a master of seat, which is always a graphical device. In this case, one of the masters of seats is the 010000 address on the PCI bus, which is card 0. So the system has randomly chosen the Polaris card to be card 0. And associated with that, there is also the render D128 and the graphics frame buffer FB1. And a little bit further down, there's the same for sound. We have card 0 for sound at PCI address 0100.1. So those are two devices which we're definitely going to want to move over to the other seat. Because as I said earlier, we need to make sure our primary graphics card is used by the first seat, seat 0. So going down a bit further, we can choose devices at any level in this tree. So we could choose this address here, USB 1, which is one of the ports of the USB root hub. Or we could choose USB 1 port 5, which in this case is a Logitech MX vertical mouse. So if we were to pass through USB 1 to our second seat, it would include all of the children devices, including this Logitech mouse and this Unicomp keyboard, but not the stuff on USB 2 or further. Now we scroll down a bit farther, we found the second graphics card, and in this case it's called card 1. Now you might think it's tempting to just pass through card 1 DisplayPort 4, but it won't work. It's going to pass through the entire card. A little bit further down we got some more USB devices. So on USB 3, which is the third port from the USB root hub on the chipset, we have the Razer Black Widow keyboard. On USB 4 we have a generic optical mouse. USB 6 has nothing. And then we have a third sound card, which in this case is card 2. And this is our high-def audio provided by the chipset. So if you need headphones, one of your users can use the headphones that are built into the chipset, the front panel audio and the rear panel analog audio. But the other user has to use HDMI audio through the graphics card. And that works completely fine, you just don't get a microphone. So if you need a microphone for both users, you're going to have to use a USB solution for the second user's microphone. So just to reference this, I'm going to send it to a file. So then I can open that file and we can reference it. So now that we know we need to pass card 0, which is not our primary graphics card, we're going to set that up first. So to attach a device to a different seat, you call login control attach. So we're going to say attach. We want to attach it to seat 1, and we're going to paste in that line we just copied from the text file. So it's the path in the sys file system to the device, which in this case is PCI address 0100 and DRM card 0. Boom. So you can't see it, but my second monitor just showed up with a login prompt. So now we're going to go back over here and copy the other devices. So because we copied this, it copies all the children as well. We also need render D128. And we need the frame buffer. The frame buffer is called graphics FB1. And we need sound. So we're again going to copy and paste this entire card. So now our second user has sound, but they don't have a keyboard and a mouse. So next up is USB devices. As you'll notice here, there's things like USB 1, USB 1-5. If we go over here and run ls USB, it'll show us what ports everything is on. So bus and device are what we need to put into login control. So it's easiest if everything is on the same bus. And that doesn't necessarily mean one port. More than one port on the motherboard may be associated with the same bus. So I recommend you take a known device and plug it into each port individually and figure out which bus that is. Now device numbers are going to be assigned sequentially when a device is plugged in. So if there are two USB ports that share the same bus, you can't tell when a device is plugged into one or the other. So now I'm going to look at the devices that are already plugged in and see which port they're attached to on the back of the motherboard. And from there, I'm going to know which ports on the motherboard share the same bus. Because we really want one bus for all of the devices for one user. So we can pass through that entire bus. And then those USB ports will always be given to the same seat. So what I've decided is bus 1 is going to be my keyboard and mouse for seat 0. You can see both my Unicomp keyboard and my Logitech receiver are on bus 1. So I'm going to leave that attached to seat 0, which is where it already is. The optical mouse is on bus 5, and the Razer Black Widow is on bus 3. So I'm going to take bus 3 and bus 5 and assign them to the second seat so that he has a keyboard and a mouse. And if there's any other ports that share bus 3 and bus 5, all of those devices are coming too. To make this easier, I suggest you buy a USB 3 hub and connect it to 2 different root ports on your motherboard. This way you can plug in devices and you'll know they'll get assigned to the right seat. And so that gives us the mouse, and we need the keyboard. Okay, so that should be our second seat. It should be up and working now. The seat should have shown up as soon as we attached the master of seat, but you wouldn't have been able to use it. Now that we've given it a keyboard and mouse, and also sound, you can go ahead and log into a user on that seat. So to let a user log into that seat, we need to create another user first. And we could do it here, or we could do it through the command line. So if my main user is called Multisystem, my second user is going to be called Subsystem. So to get a working gaming system, we don't really have to do much else at this point. Vulkan should be functional as long as the correct Mesa version is installed. I'm going to launch Steam, and Steam is going to install Mesa for me. So the first time you run Steam for Linux, it wants to do a package search. And it's going to install the packages it requires. including a large portion of Mesa, OpenGL, and Vulkan. And that should get you through pretty much all of the games that are supported correctly on Steam. One quirk I found is that Steam for Linux stores your game library in the user's home directory, as well as almost all of Steam itself. And that means if you have multiple users using the system, you're going to end up downloading the same game more than one time. Of course, if you use ZFS, you can turn on deduplication, and it should be able to figure that out. But it's still better than having 2 complete installs of Windows for virtual machines. So I'm going to log into my Steam account, and I'm going to hide that from you guys. So before I download a game in Steam, I'm going to turn on deduplication for home directories in ZFS. So here's all the ZFS datasets we get. So in Ubuntu, it creates a pool called rpool, which contains 2 separate datasets for root and user data. Root is the root file system with several subsystems, and it can snapshot these when it does updates. User data is where home directories go. In this case, there's one for multi-system, one for root, the root user, and one for subsystem. So I'm going to turn on deduplication at the root rpool user data level. So the command I'm looking for is sudo zfs set dedup equals on rpool / user data. There we go. So if we list the pool with sudo zpool list, we can see it has a dedup ratio of 1. And bpool is the boot pool. It's used by the grub loader. Not really a concern of ours. So now I'm going to download a game on both this session and the other session. So I downloaded Half-Life 2 on both instances just so we can see that this deduplication works. So now we've grown a bit and our dedup ratio is 1.72x. That means we've saved a huge amount on this 12.9 gigs here. So 12.9 gigs for rpool includes the Ubuntu system itself. So the dedup system was able to work pretty darn effectively in this case. So now that we got all this set up, let's game on it. Okay, so you got to sit on the button. Okay, now I sit on my button, you can get through. Okay, now we can both go through.
Alright, nice.
This is not a bad experience at all.
No, pretty good. It's running smoothly.
It's running perfectly smooth. Oh, I'm supposed to catch it? What? What is this? Ah! Ow! How does one get over there? So I hope you liked this introduction to multi-seat systems on Linux. Compared to the traditional methods of GPU pass-through and multiple virtual machines, this system is much more resource efficient. You also don't need to deal with single GPU pass-through or having an extra GPU just to dedicate to the hypervisor. Of course, all of that assumes the games you want to play run on Linux, but thanks to Valve and Proton, it's getting to be a much bigger list of games that are supported these days. Gaming on this system is about as you would expect for a Vega mobile or an RX 580. You get about the performance that those GPUs should get. Now, as I said earlier, this has been a long time dream of mine to see a multi-user Linux system where all the users are connected to the same computer. I know in a previous video I was able to do it with remote desktop, but this is truly a multi-user, multi-seat system, and it works with 3D applications, CAD, games, anything that needs OpenGL or Vulkan. Of course, this is just my first step in the Linux multi-seat journey. Eventually, I'd like to be able to share graphics outputs on a single graphics card, but currently it's just not that easy to set up. Of course, I'll continue working on it and post another video in the future if I can get it to work. As always, don't forget to like and subscribe, comment down below what you thought of the video, or any suggestions you have. I also just started a Discord server, so if you're really interested in home lab and Linux, go check that out too.